The next concept is pointers and classes, or relationship between pointers and objects, or relationship between pointers and classes. What we are going to explain in this concept, relationship between pointers and objects. How to access members of class using pointer. See, class variables we call it as objects, on which we concentrate on this topic, that is relationship between pointers and objects. How to access members of classes using pointers, that is the agenda of this concept. See here, how to create a class. We all know class is a user defined data type. So using this we can create any number of objects. Let us consider class student. The data members are like this: char student name 20, int student ID, then I'll take combination here. Now in the public section, so these are all data members of a class. Yes name, combination and SID are belongs to private section of the class. I did not mention access specifier. So which is the access specifier? Private is the access specifier. To access private data, we have to write a function as usual. First, let us understand what we learned in the class and objects chapter. How to read, how to access members of class. If it would be private member, we have to write a member function in the class to access that private data. So I'll write a function void input. These things we already know in previous chapters: function overloading, constructors and destructors, inheritance. We have written many programs on class and objects, and we had taken functions like this: cout, enter student name, student ID and combination, cin, extraction, yes name, extraction, SID. In which order you had taken the statement here, according to that order you have to read the values, combination. So this function meant for get a value from the keyboard, and another function I will take to display the content, void disp cout. I'll display like tabular format. First I want to display student ID, SID. Here we have written the thing what we are going to display, what is the content of that data member. Directly we have to write the data member here, and I'll give \t. After SID I want to display yes name. Then I want to display combination here, then \n semicolon. Now cout, insertion, only 3 members are there now, so let us close. Main, let us write a main function here, void main. I want to read 2 student details here, so I have to create object. The data type is student, S1 and S2 are the objects. You all know when we declare objects, memory will be allocated for these two objects, S1 and for S2 also. Now, what are the members? Yes, name, combination and student ID. Here also, yes, name, combination, student ID. These are the data members of each object, and every object having its own memory address. I'll take 500 and 700. Random allocation will be takes place. Now I want to read values for S1 and S2. To read values, I have written instructions, these two instructions in this module, this function. So to execute these instructions, I have to call this function. On which object these operation has to be performed, that object, using that object I have to call this function. Right now I want to read values for S1 object. So I have to call this function, input function, using S1. S1 dot input, open close semicolon. Okay. And to read S2, I have to call S2 dot input. Now I want to display in a tabular format. Let us write a statement here. Cout insertion. First I want to display SID \t, yes name, student name \t, then combination \n semicolon. Then which function is there to display the contents of each object? Disp function is there. So disp function will display the contents, values S1 and S2. Whose value I want to display? We have to call that function using that object. S1 dot disp. In which format I have written instruction here. According to that I have to write a heading here, so that it will be matched with that statement. Disp S2 dot disp. Close. This is a normal way of accessing members of a class. What happens when we create object? Memory will be allocated. Then S1 dot input, which function will be invoked here? Input function. With which object, using which object? S1 object. So what does it mean? It has to read values for S1. So I'll write output screen here. Assume this is output screen. So first statement will be like this: enter S name, SID and combination. So here I'll give a statement. Before going to call, let us write a statement. Enter first student details. First student details. Then it will be displayed. Before that, it display enter first student details. After that, I'll call function input function using S1 object. Then it display these instructions: enter yes name, SID and combination. So let us assume yes name, I'll take Ram, student name, SID 111 and combination PCM CS I'll take. Now after that I'll write one more instruction here: enter second student details. So it will be displayed on the screen. If I had written these two instructions, then only it will be displayed on the screen. Enter second student details. After that S2 dot input is there. This input function will be invoked again, but now the values are goes to S2 object. Enter yes name, SID and combination. So now the values are like this: Surya, I'll take a name Surya 121 and combination is PCM-CS. Now this statement will be displayed on the screen. SID, I'll continue here, the output I'll continue here. SID, after that \T is there, then S name, then combination. Now what is the next instruction? S1.disp. S1.disp means this function, display function will be invoked, whose value it has to display, which object is calling S1 object, so it has to display the values from S1. What is there in the S1? So these three values are stored in S1, no? RAM 111, then combination PCM-CS. Here Surya 121, sorry, okay, 121. Now the values are coming from a respective object. S1 is calling display function, so RAM, sorry, SID, no, first I am extracting SID. SID is 111 and S name is RAM and combination is PCM-CS. Next, SID, whose value I want to display? S2 object. So what is there in the SID? 121 and S name Surya, then combination is PCM-CS. In this way display, this is a normal way of accessing the members of structure. But in the question, we have to use a pointers and classes or pointers and objects. So what we are going to do here is, to these objects I have to create a pointer. That is a thing here. So instead of writing main like this, I will change the main. This is what we have learnt in the previous chapters or in the class and objects chapters. Now let us access the members of class using pointers. That we need to explain here. Now I'll write main here. Void main. What is the data type? Student. S1, S2, star P1, comma star P2. P1, P2 are the pointers of which type? Student type. When I write these statements, as usual, memory allocation for S1, S2 and for P1, and for P2. 200, 300, 500, 700. What are the things included in these two objects? S name, SID, combination. S name, SID and combination. Now let us store the address of these two objects into these pointers. How to store address? P1 is equal to ampersand S1, P2 is equal to ampersand S2. In this way we have to store the address of these two objects. So what is there in the P1 right now? Address of S1. What is the address of S1? 200. P2. Address of S2. What is there? 500. So P1 200, P2 is 500. So these two addresses are stored in these two memory locations, these two pointers. Now how to access the member of class? First I want to read values for object S1, but I should not use object name here. I have to use pointer name. How? If I use P1, what does it show? 200. P1 contains the address of S1. So it shows 200. I want to move into this memory location, S1 memory. So I must write star here. If you write only P1, it shows the memory address. If you write star P1, then it move into that memory location. Now I have to access the members. How to access? In order to read these members, we have a function called input function. How did we access this function in the previously what I had written in the main function? We used S1 dot input. So instead of S1, I have written star P1. So I must use dot input open close semicolon. Isn't it? So instead of S1, I have written star P1 and dot operator. This is a way to access a member. But the same thing here also. Dot operator having higher priority than star operator. So in order to execute star operator first, I have to write a parenthesis here. So that star operator will be execute first, then dot operator. Star P1 means it moves into the S1, then S1 dot input function. What does it mean? Star P1 andre S1 iddange. S1 dot input anta bariyo badlu star P1 dot input. And in the previous concept, that is the relationship between pointers and structures, we discussed that star and dot operators are replaced by arrow operator. So I can write like this: P1 arrow. Now I'll use P2 arrow input. To read values for S1 and S2, we have a function called input function. To read values for S1, I have to call this function using S1 object, but I used pointers to these objects. So instead of using object's name, I used a pointer's name. Star P1 represents S1. So star P1 dot input. Here that star and dot operators are replaced by arrow operator. That's why I have taken P2 arrow input. To display, I can use P1 arrow disp. Here P2 arrow disp. Like this we can show the relationship between pointers and objects or pointers and classes. See that relationship between pointers and class or pointers and objects anta kelidre classina members na yav tara access ಮಾಡಬೇಕು pointers use ಮಾಡಿ. So object create ಮಾಡಿ ಆ objects ಗೆ pointers na ತಗೋಬೇಕು. These two pointers has to contain the address of these objects. Objects are nothing but variables of class type. ಹಿಂಗೆ ನೀವು ಬೇಸಿಕ್ ಟೈಪ್ ತಗೊಳ್ತಾ ಇದ್ರಿ, ಬೇಸಿಕ್ ಒಂದು ಇಂಟೀಜರ್ ವೇರಿಯೇಬಲ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ, ಒಂದು ಇಂಟೀಜರ್ ಪಾಯಿಂಟರ್ ತಗೊಳ್ತಾ ಇದ್ವಿ. ಸೊ ಆ ಇಂಟೀಜರ್ ಪಾಯಿಂಟರ್ಗೆ ಆ ವೇರಿಯೇಬಲ್ ಅಡ್ರೆಸ್ನ ಸ್ಟೋರ್ ಮಾಡಿ ವೇರಿಯೇಬಲಲ್ಲಿರೋ ಕಂಟೆಂಟನ್ನು ಪಾಯಿಂಟರಿಂದ ಆಕ್ಸೆಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಅದನ್ನೇ ಕಂಪೇರ್ ಮಾಡಿ ನಿಮಗೆ ಇದು ಬೇಗ ಗೊತ್ತಾಗಿಲ್ಲ ಅಂದರೆ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಅ ವೇರಿಯೇಬಲ್, ನಾರ್ಮಲ್ ವೇರಿಯೇಬಲ್, ಈ ಥರ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ನೀವು. ಇದು ಬೇಗ ಗೊತ್ತಾಗಿಲ್ಲ ನಿಮಗೆ ಅಂದರೆ ಯು ಕ್ಯಾನ್ ಕಂಪೇರ್ ಲೈಕ್ ದಿಸ್: ಇಂಟ್ ಎಕ್ಸ್ಗೆ ಒಂದು ವ್ಯಾಲ್ಯೂ ಕೊಡೋಣ, ವೈಗೆ ಇನ್ನೊಂದು ವ್ಯಾಲ್ಯೂ, and I'll take two pointers P1 and P2. Let us store the address of x into P1 ampersand x and P2 is equal to ampersand y. You can compare this with the basic data type so that you can understand easily. Instead of int, student is there. ಇಲ್ಲಿ S1 S2 ಅಂತಿದೆ, x y, but here I have taken value, I have initialized the value, x ಅಲ್ಲಿ value ಹಾಕ್ಬಿಟ್ಟಿದ್ದೀನಿ x y ಗೆ. Now I want to display x and y value, but we should not use x and y. I have to use pointers. How? Cout insertion x is equal to star P1. ಬರೀ P1 ಅಂತ ಬರೆದ್ರೆ ಏನಾಗುತ್ತೆ? P1 ಅಲ್ಲಿ ಏನಿದೆ? x ನ ಅಡ್ರೆಸ್ ಇದೆ. ನನಗೆ x ಒಳಗಡೆ ಹೋಗಬೇಕಂದ್ರೆ ಸ್ಟಾರ್ P1. ಅದೇ ಥರ ವೈದು ವ್ಯಾಲ್ಯೂ ಡಿಸ್ಪ್ಲೇ ಆಗಬೇಕು. Who has to display? P2 has to display. Star P2 I can write here. The same thing you can compare. S1, S2 are the variables of which type? Student type. P1, P2 are the pointers. They also student type. The P1 contains the address of S1. P2 contains the address of S2. Now I want to read values for S1. So I have to call input function using S1 object. but I should not use S1. I have to use pointer. Then how does that pointer is equivalent to S1? If I write star P1, then star P1 is equivalent to S1. Then ಈಗ ಇದನ್ನು ನೀವು S1 ಅಂತ ಅನ್ಕೋಬಹುದು. ಸ್ಟಾರ್ P1 ಅಂದ್ರೂ ಒಂದೇ, S1 ಅಂದ್ರೂ ಒಂದೇ. Dot input. The same thing will be applied here. I hope you understood this relationship between pointers and objects. Let us understand the next concept, pointers and functions. See, on these concepts, different concepts, I had taken only one example on each concept. At the end of this chapter, I will discuss with the more example on these concepts. Right now, let us understand the concept and let us understand the program based, one program based on this concept. Pointers and functions. Functions are nothing but they are modules or a self-contained instructions, a unit which contains certain instructions to perform certain task or required task. That is a function, isn't it? See, what is the relationship between functions and pointers? You all know pointers are nothing but variables. Basically they are variables and they store the address of other memory location. So functions are used in a program to perform different tasks and to make the program more clarity and to debug easily, and for reusable purpose we will use the functions. Now how to pass values to functions? We already discussed in the last year calling functions or calling functions and defining functions. How to define functions? There are 4 methods in user defined functions. Functions with argument with return value, with argument no return value, with argument with return value, no argument and no return value. Any program can be implemented either on any of these methods. Depends on the problem statement, we have to choose which method is better. A function can be written in different ways, with argument with return, with argument no return, no argument with return, no argument no return. Based on the problem statement, we have to choose which method is better or best. Okay. Now, to write a function, we have to follow certain rules. We have to declare functions, we have to call functions, and we have to define functions. In order to write our own function, user defined function, we should have the knowledge about these things. Now let us consider functions with argument. I have to pass some arguments to the function. I'll take a function. Let us start with the example swapping of 2 integers using functions. I discussed this program at the beginning of the second year class. So swapping of 2 integers. Usually we pass the values of a variable from one function to another function. That is called by value method. So call by value means passing a value from one function to another function. Let us write the program here. Methods of calling functions. Call by value These concepts I discussed in the class and objects chapter, that is object as function argument. There we concentrate on how objects are passed from one function to another function. There also we discussed call by value and call by reference. We discussed call by reference there. Okay, how to pass an object to the function in two ways. One is call by value, another one is call by method. In this program, in this concept, in this chapter, pointers chapter, I'll show what is the relationship between pointers and functions. So, but in your syllabus, again they have introduced call by value and call by value, call by reference and call by address in this chapter. So I explained the same, call by value and call by reference, already you know that, just I recall that. And main thing is call by address, that is related to pointers. Call by value, call by reference, call by address. See, this third method is there, no? In this method we use pointers, and these two methods, first we have to understand these two methods and we can come to know what is the difference between this call by address and call by reference. In that way they have taken examples in your syllabus. So I will go with the same. First, call by value, I will consider a program here. Header files, void main, further I will write a function. That function does not return a value, so the return type specifier is void. Name of the function I will take modify. I told swapping of two numbers I will take, but now I will take a simple program, that modify function. To this function I will pass an integer. So what you can understand by this statement, there is a function, user defined function, its name is modify. This function takes one argument, that is integer type argument, from the main function. After performing operation, that function does not return any value to main function, so the return type specifier is void. Now the thing is, main has to pass an integer value to this function. That's why to store value I must declare a variable here, int x. Cout, enter an integer, cin extraction x. Now I have to pass this value to the function modify. The name of function is modify. So let us display before modification, cout before modification, cout x is equal to x. Let us call modify function modify, and I will pass x. What we understood by seeing these statements, first we declare a variable, and to that variable I will enter a value. So that's why I have written cin statement. After that, once I display the content of that variable, what I had given here, after displaying that, let us call a modify function. So what we thought, there is a function, this function modifies the values of x. So after execution of this function, what we understood, the value will be modified. Let us display the modified value. Cout insertion x is equal to, so I will write after modification Cout x is equal to x. So what we thought by seeing this example, before modification I display the value of x and we'll call the modify function. This function modify the value. Then after modification we thought the value will be modified, the x value will be modified, and I'll display the content modified value, then it ends the program. So we thought like this when we see this main function. So let us write the function, that modify function here. Void modify. To this function I have to pass value. So I took value here, x value will be passed here. To receive this value I have to take a variable. What type of value is coming? Integer type. So I'll take integer, I'll take n here. Here I'll modify. N is equal to n plus 2. Only that instruction will be there in this program, in this function. So this function modifies the value of n, that the content of x. The content of x will be modified from this function. After that, the remaining statements will be executed. Then how does the output? Let us see here. When I write this instruction int x, what happens? Memory will be allocated for x. I'll write. So let us consider this is the output screen. When we write this instruction, what happens? Memory will be allocated. X, I'll take address is 700. After that, enter an integer. This statement will be displayed on the screen. Enter an integer. So what is the value? Let us consider 10. So the 10 will be stored in x. After that, before modification, this statement will be displayed on the screen. Before modification, x is equal to x. What is there in the x? 10 is there, so it will be displayed. What is the next statement here? Modify is there. So what does it mean? Further there is a function called modify. Its name is modify. So this is a function invocation. This is called function call. Function call. The value of x will be copied to n. Now n also 10. Int n means declaration of variable, so there is a memory for n. Let us assume the address is 500. So n also contains 10. The value of x is copied to n. Now when it enters the function body, n is equal to n plus 2. What is there in the n? 10 is there. 10 plus 2, 12. 12 will be stored in n itself. So 10. The content 10 is incremented by 2, so it has become 12, but not in the original variable, it is in the formal variable. Okay, but when you see this program, when you concentrate on only main function, what you can understand, this value is modified by this function. After modification, after execution of this function, again control comes to the main function and remaining statements will be executed. So we thought that value is modified. Yes, of course the value is modified, but not in the actual argument. It's modified in the formal argument. So after you display this, after modification, x is equal to, what is there in the x? Still 10 is there. 10 will be displayed. But what we thought, we called a modify function. To that function I passed 10. The 10 will be modified. So I'll get a modified value. But the thing is different. That value will be modified from this object, this variable, that is a formal variable, not from the actual variable. So that is the disadvantage of call by value. Let us move to the call by reference. Then what actually happened in call by value? Value of actual argument is passed to the formal argument. So that is the key point here in a call by value. Value of actual, when we call a function in call by value, when we call a function, the value of actual argument will be passed to the formal argument. So any changes or any modifications are done on formal argument will not be affected to the actual argument. That is the disadvantage of call by value. Now call by reference. I'll consider the same example here. So what is the difference between call by value and call by reference? Instead of passing value, we have to give the reference of that variable. How? We must write ampersand operator here. Where here? This is a prototype now, function prototype. If you add this ampersand operator, what does it mean? Address of actual argument is referred by this variable. See here. This is an actual argument. X is an actual, I'll write here. Here I'll write X. When I declare X, memory is allocated here 500. So if you add ampersand operator here, the address of this memory X actual argument is referred by N also. So N also refers the same memory location. Before in call by value, there were two memory locations. Two set of memory locations were there. One for X, another for N. In call by reference, there is no separate memory for formal argument. That formal argument refers the address of same memory, that is actual argument memory location. So if you make any changes on that value, either using actual argument or formal argument, it affects the same memory location. It affects the value that is stored in the same memory location. If I take X is equal to 10, if I read value 10 for X, it will be stored in X, and the X value is 10. Here value will not pass here. Right? X in a value hogalla. Illi ampersand use madidhi. We used ampersand. So N also refers the address of X. Value pass agode illa illi. N kuda ide memory na refer ಮಾಡ್ತಾ ಇರುತ್ತೆ. Now what is the address of N? That is 500. 500 also refers the same memory. N also refers the same memory, that is 500. If you make any changes on the data using N is equal to N plus 2. What is N? N is an identifier. Which memory identifier? 500. The memory address is 500, whose identifier is N and X. So N plus 2, 10 plus 2, 12. 12 will be stored in N itself. N andre ide memory net. So 12. So X andru ade, N andru ade memory. So if you make any changes on this data, either using either variable, it will be affected to the original memory location. So that is the advantage of call by reference. Let us come to call by address. So in call by value, we pass the value of a variable, actual variable or actual argument. Call by reference, we pass the reference of the actual argument, isn't it? We did not pass a value here. We used the ampersand operator, address operator. It refers the address of actual argument. In call by address, name itself indicates call by address. We have to pass the address of actual argument. See here. Let us start from here. Int X, so there is a memory for X, 2-byte memory. Its address is 500, is the assumption. Enter an integer. I'll take a 10 here. After that, before modification, X is equal to X. So it will be displayed. Before modification, X is equal to X will be displayed. Now modify function. So to this function, I have to pass the address of actual argument. Here name call by address anta ide. Address andre actual argument address na pass ಮಾಡಬೇಕು. which is the actual argument here? X is the actual argument. The address of X is passed to the formal argument. How to pass the address? We must use ampersand operator here. These minute changes you have to observe. That is the difference between these three methods. Here I am passing the address of actual argument. To receive the address or to store the address of a variable, we need a memory location. That memory location is such a way that it has to store the address of variable or address of memory location. Then that variable must be pointer. Are you understanding? See, I am passing the address of actual argument. X is an actual argument. So its address is going here. It's going to this function. To store this address, X address, I need a memory. Here I need a memory. Let us assume the address is 700. This memory it must have the nature to store address of another memory location. Okay, so ಯಾವ ತರ ಇರಬೇಕು ಈ ಮೆಮೊರಿಗೆ ಎಂತ ಫೀಚರ್ ಇರಬೇಕು? It has to store the address of another memory location. Then it should be a pointer, isn't it? So I have to declare pointer in the function header star n. I'll take star n. Now n is not a normal variable, it is a pointer. What is there in the pointer? The address of X will be stored in n. What is the address of X? 500 is the address. That 500 will be stored in n. Understood? So in this way I can pass the address of actual argument to formal argument. So X is an actual argument whose address is going to this function. To receive that address I have taken a pointer. That pointer is an integer type. It stores the address of X. In the function prototype I must write a star operator, because further I will take a pointer. To indicate that I have to take star operator. Now what is there in the n? Address of X. If I write only n, what happens? N shows the address. I want to modify the content of X. What is there in the n? X address is there, 500 is there. How to move into the X? Star n. I must write star n. Star n anta baradre yadakke equivalent? Star n is equivalent to X. Star n plus 2. Star n plus 2 andre X idange. ಅದೆಲ್ಲಿ ಸ್ಟೋರ್ ಆಗಬೇಕು? ಮತ್ತೆ ಎಕ್ಸ್ಗೆ ಸ್ಟೋರ್ ಆಗಬೇಕು. ಎಕ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ಸ್ಟಾರ್ ಎನ್. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ ಬೈ ಅಡ್ರೆಸ್. ಸೊ ಪಾಯಿಂಟರ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಇನ್ ಕಾಲ್ ಬೈ ಅಡ್ರೆಸ್. I hope you understood what is the relationship between functions and pointers, and these two things first I explained to understand the difference between call by address and these two. So sometimes they'll ask explain call by value and call by address, or call by reference and call by address. They'll ask what is the difference between call by reference and call by address, or explain call by address. So how to give the explanation? In call by address the actual argument address will be passed to the formal argument. So the formal argument must be a pointer to receive the address of actual argument. Then you have to write program to illustrate call by address. In this way you can write the explanation. Next concept, pointer arithmetic. So what are the arithmetic operations, basic arithmetic operations? Addition, subtraction, multiplication, division, increment, decrement. These are the operations or modulus operations of arithmetic operations. What type of operations we can perform on pointers and what type of operations we cannot perform on pointers? See here. Let us consider a floating type variable. Float P. This is a pointer, floating type pointer. There is a memory allocation. How many bytes it would be allocated? 2 bytes. Though it is a floating type pointer, it's a 2-byte memory will be allocated. I told you pointer, whatever the type of pointer, it occupies 2 bytes because it stores the address of memory location. Let us consider 500 address. And I'll take a variable float n. It's a normal floating type variable. The address is like this 700. This is 4 byte. It's a normal variable. It's a pointer. This is 2 byte. Okay. Now I'll take some value here 2.6. So 2.6 will be stored here. If I write like this, I want to increment the content of n using p. How? First I have to create or I have to generate a link between these two. How? P is equal to ampersand n. Now I can operate. Now I can perform certain operation on n using p. Unless you generate a link between this pointer and this variable, we cannot perform operation on n using p. ಅಲ್ವಾ? ಈಗ n ಒಳಗೇನಿದೆ 2.6 ಇದೆ, ನಾನೀಗೇನೋ ಮಾಡಿಫೈ ಮಾಡಬೇಕು, ಈಗ 3.6 ಮಾಡಬೇಕು, ಇನ್ಕ್ರಿಮೆಂಟ್ ಮಾಡಬೇಕು ಅಥವಾ ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡಬೇಕು ಅನ್ಕೊಳ್ಳಿ. ಐ ಶುಡ್ ನಾಟ್ ಯೂಸ್ n, ಐ ಹ್ಯಾವ್ ಟು ಯೂಸ್ p. p ಇಂದ ಇದನ್ನು ಮಾಡಬೇಕು ಅಂದರೆ ಇದಕ್ಕೆ ಫಸ್ಟ್ ಲಿಂಕ್ ಜನರೇಟ್ ಆಗಬೇಕು. ಹೌ ಟು ಜನರೇಟ್ ಅ ಲಿಂಕ್? ವಿ ಹ್ಯಾವ್ ಟು ಸ್ಟೋರ್ ದ ಅಡ್ರೆಸ್ ಆಫ್ n ಇಂಟು p. ಹೌ ಟು ಸ್ಟೋರ್ ದ ಅಡ್ರೆಸ್? ಲೈಕ್ ದಿಸ್, p is equal to ampersand n. Then the address of n will be stored in p, 700. Now we can modify the content of n using p. I can write like this, star p, how to write the pointer which has to equivalent to n? Star p. Star p is equal to star p plus 1, or you can write or star p plus plus. Star p is nothing but n alva. P anta baradre address of n, star p means content of n. So here star p plus plus means the n value will be modified, 3.6. So using pointer we can modify the content of a variable. That variable is pointed by that pointer. So this kind of operations I can perform. We can subtract, we can decrement the value of a variable. That variable is pointed by the pointer. Understood? We cannot perform multiplication and division operations on pointers. Why? Addition and subtraction on pointers is nothing but multiplication and division. See here, in this example I performed operation on the content of the variable. That variable is pointed by the pointer. Let us consider another example. I have taken integer pointer and I have taken floating type variable, normal variable. So let us assume this is a RAM and these are the memory cells in the RAM. When I read this statement, somewhere 2 byte memory will be allocated for the pointer. I'll consider 308 and 309. So its name is P1 and 2 byte. There is a variable, that is floating type variable. Somewhere 4 byte memory will be allocated. I'll consider 600, 601, 602, 603. Its name is X and this is 4 byte. Content is 10.2. 10.2 will be stored in this memory location. Now I want to store the address of X into P1. Though it is different type of pointer, I can store the address. So in order to store, there is no issue. To perform certain operation, then we have to face some issues here. P1 is equal to ampersand X. ಇಲ್ಲಿವರೆಗೂ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗೋದಿಲ್ಲ. ಈಗ X in the address, what is the address of X? 600. First address we have to consider. 600 will be stored in P1. Okay. 309. Next memory, here I'll take this is 310, 311, this is 307, 306, like this. If I decrement this pointer, okay, P1 minus minus. Right now this pointer pointing one floating type variable. Now I will decrement that pointer to display another floating type value. So let us consider another floating type variable here. I'll take y is equal to $10.1. Suppose the y also allocated here 304, 305, and its value is 10.1. Wait, I'll take simple example. .303, 304, 305 and 306. These 4 byte memory will be allocated for X. Now P1 is equal to ampersand X. The address of X 303, 303 will be stored in P1. If I decrement P1, what happens? Right now P1 points which memory location? 303. Okay. So if I decrement P1, what type of pointer it is? Integer type pointer. Then how many bytes it occupies? 2 bytes. Now when I decrement this pointer, at one time decrement, it move backward by 2 bytes. Now 301 will be stored in this pointer. So we can perform decrement operation on pointer. So what happens when you increment or decrement, it doesn't mean that it will be increment the value. ಅಂದರೆ ವ್ಯಾಲ್ಯೂ ಇನ್ಕ್ರಿಮೆಂಟ್ ಆಗೋದು ಅಂತ ಅಲ್ಲ, ಮೆಮೊರಿ ಅಷ್ಟು ಬೈಟ್ ಮೂವ್ ಆಗುತ್ತೆ. ಯಾವ ಟೈಪ್ ಪಾಯಿಂಟರ್ ಅದು, ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಮೂವ್ either forward or backward, depends on the operation. If it is decrement operator, it will move backward by amount of memory that is required by that pointer. ಈ ಪಾಯಿಂಟರ್ ಯಾವ ಟೈಪ್, ಇಂಟೀಜರ್ ಟೈಪ್. ನಾವು ಆ ಪಾಯಿಂಟರ್ನ ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡಿದ್ರೆ, ಇಫ್ ಯು ಡಿಕ್ರಿಮೆಂಟ್ ದಿಸ್ ಪಾಯಿಂಟರ್, then it decremented means the value will be decremented by amount of memory that is occupied by this pointer. How much memory it occupied? 2 bytes. So when you decrement this pointer, right now it's pointing 303. ನೀವು ಡಿಕ್ರಿಮೆಂಟ್ ಮಾಡಿದ್ರೆ ಅದು ಎಲ್ಲಿ ಪಾಯಿಂಟ್ ಮಾಡ್ತಾ ಇದೆಯಲ್ಲ ಅದಕ್ಕಿಂತ 2 byte ಹಿಂದೆ ಹೋಗುತ್ತೆ. ಇದು ಅಂದರೆ 301. ಇಟ್ ಮೂವ್ಸ್ ಟು 301. ಇಫ್ ಐ ಇನ್ಕ್ರಿಮೆಂಟ್ P1 ಇನ್ಕ್ರಿಮೆಂಟ್ ಮಾಡಿದ್ರೆ ಬಿಫೋರ್ ಇಟ್ ಪಾಯಿಂಟ್ಸ್ 303. ಇಫ್ ಐ ಇನ್ಕ್ರಿಮೆಂಟ್ P1 303 ಇದ್ದಿದ್ದು 2 byte ಅಂದರೆ 305, then it points 305. Understood? But when we perform some operations on the memory locations, contents of memory locations using pointers, we have to take compatible pointers. Okay? In the next class, I will show how to take a compatible pointer, why we should take compatible pointer to perform certain operations on the variables. I hope you understood what is the first operation we can perform on pointer. We can perform addition operation on pointer, increment and decrement operations on pointers.